Okay, this question is going to be looking at question 5, or this video is going to be looking at question 5, part A of the June 2014 Edexcel FP1 paper. And it says, use the standard results for the sum of r and the sum of r squared to show that the sum of 2r minus 1 all squared is equal to a third n all multiplied by 4n squared minus 1. Okay, so basically it's a 6-mark question. Okay, so there's quite a lot of marks there. And basically what it's testing is, do you know the standard results for sum of r and sum of r squared? Okay, I've written them down there. It's worth committing them to memory because, as you can see, this is just part A. There is this part B, which I'm going to do in another video. But this is just part A, and it's already worth 6 marks. Okay, and really the hardest thing here is knowing these two results. Sum of r is equal to a half n times by n plus 1. And the sum of r squared is equal to a sixth n times n plus 1 times n plus 2. 2n plus 1. Okay, if you know that, you're laughing really because they're not difficult marks at all. Okay, there's a little bit of algebra involved, but it's not that difficult. So how would I tackle this question? Well, first of all, I'd start with the left side because I know that if I can get it into a point where I've got sum of r and sum of r squared, and the question even says use the standard results for sum of r and sum of r squared, then hopefully I can manipulate it and I can make it look like the right side. Okay, I kind of rely on my algebraic manipulation and ability to do that. Whereas if I'm starting from the right side, that suddenly becomes a lot more difficult to get it back in this form. In fact, it's going to take forever to do because what will quite often happen if you work from left to right, as I'm going to show you, the way which I'm going to do it, there'll be terms which cancel, okay? Whereas if you're working from right to left, those cancellation terms will be really difficult to get back, okay? So yeah, and actually I don't think no marks are awarded if you're working from right to left. You have to work from left to right because the question says use these standard results. But anyway, this is how I would do it. So we've got, just write the question out again, sum from 1 to n of 2r minus 1 all squared. Okay, and I want to try and manipulate that to make it look like this. So, first things first, I see this as quadratic, expand it. Brackets, whenever you see algebraic manipulation, okay, if ever you see brackets and you want to try and manipulate it, try and get rid of those brackets, because brackets almost act like a barrier, okay, and if you can break that barrier down, then you could do more with it, okay, so let's break this barrier down. So we've got, still got the same summation from 1 to n. Let's expand this thing out. It's just an ordinary quadratic, so it's 2r minus 1 multiplied by 2r minus 1. I can do that in my head. If you have to write out two brackets, there's no harm in doing that. Okay, so we got 2r minus 1 all squared. So we got 4r squared minus 4r plus 1. Okay, and then what I want to do is this is a summation of all of that. Well, it's got 3 terms inside this bracket. It's got 4r squared, that's one term. You've got the minus 4r, that's another term. And you've got the 1, that's another term. Okay, and because I'm summating 3 terms, that's the same as summation of the 3 terms individually. So I'll show you what I mean. Okay, I can go the summation of from 1 to n of 4r squared, the first term, minus the summation of the second term of 4r, plus the summation of the last term, which is just 1. Okay, right, well, let me just do a little bit more. Okay, this is just a constant. The 4 and the 4 here are just constants, so I can multiply that, take that constant in front of the summation. Because if I summate, it's the summation of r squared, the 4r squared, is the same as 4 times the summation of r squared. Okay, it's just being multiplied by a factor of 4. That's all it's doing. So of r squared minus 4 times the summation of r equals 1 to n of r plus the summation from r equals 1 to n of 1. Okay, and I know the summation of r squared. I've got it written down here. It's 6th n. I'm actually just going to move this over here, actually, just to give me a little bit more work. So all I'm doing is, it's still equal all this, but instead of writing it directly underneath, I'm just moving it to the left, just to give me a little bit more space. So 4 times, if you remember the summation of r squared, it's 6th n times n plus 1 times 2n plus 1. Okay, and then that's minus 4 times the summation of r. Well, the summation of r is a half n times n plus 1. So I've got minus 4 times a half n times n plus 1. And then the summation of 1, okay, be careful here, because the temptation is just to put plus 1 on the end, because you just think, oh, it's just a constant, you're just plussing the summation of a constant, oh, it's just 1. No, okay? Because remember what it's basically doing, the summation of, let's say, r from 1 to n of 1 is the same as saying 1 plus 1 plus 1 plus 1 plus, and you keep going, how many times? N times, okay, because this just basically acts like a counter. So when r equals 1, you're just going to get 1. When r equals 2, you're just going to get another 1. When r equals 3, you're just going to get another 1. When r equals 4, you're just going to get another 1. When r equals n, you're just going to get another 1. You're going to add them together n times. So what you're effectively doing is n times 1, which is n. So the summation from r equals 1 to n isn't 1, it's n. Okay. So that's just a little sort of hopefully a visualization of why that should be. Okay, and now it's just a case of doing a little bit of manipulation. Okay, so if you get that all correct, you automatically get 3 marks. In actual fact, if you expand this thing, the first step, okay, if you recognise the first step, expanding this thing, you get 1 mark. So already, if you get it to this point, you've got 4 marks out of 6. The final 2 marks are really just just getting the final answer, because it's not a lot of work from here. By the way, if you put in at least 1 correct, so if you can't remember, say if you can remember the summation of r is a half n times n plus 1, but you don't remember the exact summation for r squared, as long as you sort of attempt to get it, you will still get 1 mark out of those 3 here. So you get 1 mark for expanding it. Okay, everybody can pretty much get that mark. If you then make a correct summation for either r squared or r, you get another mark. Okay, and you also get then another mark for the correct interpretation of the sum from 1 to n of 1, which is what I've just showed you, and that's n. Okay, and if you get that all correct, then you get 3 marks. So basically, if you evaluate basically you get a mark for evaluating each one of these things correctly, is what I'm trying to say. Okay. So where would I go from here? Well, first things first, I would combine these. I wouldn't expand the brackets just yet. I would combine these fractions together, these numbers. So here I've got 4 over 6, which is the same as saying 2 over 3. Okay, because the 4, the 3, they've got a common factor of 2, so I can cancel. 4 over 6 is the same as 2/3. That's all I'm saying. Okay. And that's still multiplied by n plus 1, 2n plus 1. Okay, then minus 4 over 2, well that's the same as saying 2. Okay, 4 divided by 2 is 2. n plus 1 plus n. Okay. Now here it's actually worthwhile to look at what the question is telling us. We want to try and we've just expanded everything out to this point here. Okay. And we want to try and make this thing, which we've just expanded, look like this thing. So you can see here we've got a third and an n, and then we've got the rest multiplied by 4n squared minus 1. So basically we want to try and factor out a third n of everything that we've just got now. So everything we've just got now, we want to try and take out a third n. We can take a third out of here, that's fine. We can take a third out of here. You may not look at it because it's not over 3. And the same thing here, we can also take our third out of here because it's just, it doesn't look it because it's not over 3, but we can make it look like it's over 3. Okay, so I'm going to make everything, all these numbers over 3 first of all. Okay, because here you've got 2 and here you've got a 1. I'm just going to write that 1 in there. So 2 over 3n, n plus 1. You can put a number over anything you like as long as you know how to manipulate it, so you can. Then here, well, you've got to ask yourself, we want something over 3 here, okay? Well, you can, at the moment this is over 1, so you can multiply the bottom by 3 and the top by 3 and you get 6. Or, equivalently, you could ask yourself, well, what divided by 3 gives you 2? So you multiply by 3, 2 by 3, and you get 6. Okay, a couple of ways of thinking about the same thing. And likewise here, the moment you've got 1, you want to make it over 3, so you can either multiply the top and the bottom by 3 to get it over 3. Okay, or you can say to yourself, well, what divided by 3 gives you 1? Well, it's going to be 3, isn't it? Okay, now we've got everything over 3, we can take out a third. But we can also take out an n because we've got an n in this term, we've got an n in this term, we've got an n in this term. So let's take out a third n. And we're left behind 2 multiplied by this thing. Remember, we've taken out a third of the n. So 2 multiplied by n plus 1 multiplied by 2n plus 1 minus 6, taking out the third and the n. We're left with n plus 1 plus, well, we've taken out the over 3, the third and the n. So we're just left with the 3 here. Okay. So we've now got pretty close to what this is. We basically just need to fiddle around with what's inside. We've got the third and the n, third n out the front. We just need to fiddle around with what's inside the brackets to get 4n squared minus 1. And that shouldn't be too difficult, basically, as long as you just follow your nose. So expand this thing, and then just a little bit of simplification. So third n. Let's have a look. 2, and let's expand this. This is a quadratic. So 2 multiplied by 2n squared plus n plus 2n, so we've got plus 3n inside the brackets, plus 1 still. And then we've got minus 6 times n. Be careful, because it's minus 6 times all of this thing, not just 6. Okay, so you're going to get the minus 6n, but you also get the minus 6 at the end. Everybody sort of almost forgets this and just puts plus 6. It's not, it's a minus 6. Then you've still got a plus 3 here. Okay, and then let's just do a little bit of simplification now, gathering together like terms. So 2, let's multiply the 2 out across everything first. So we've got 4n squared plus 6n plus 2 minus 6n. I can see immediately those two things are going to cancel. We've still got the minus 6 and the plus 3. So we got a third n times 4n squared. 6n's have already cancelled. Then we've got the plus 2 minus 6 plus 3. That's going to be minus 1. And there we go. There is the final answer. So if we take out a third here, that is the extra mark. So we've always got 5 out of 6 if we can recognise take out the third, or the third n. Okay, and then you get a full mark for the answer. If you do it a slightly different way, as long as you get the right answer, they should award you the full 6 marks. But to be honest with you, that is fairly following your nose stuff.